Hello again. In this video, we're going to do a horizontal asymptote example and take a limit as x goes to negative infinity. I could have just as well went to positive infinity, but I chose negative just because. But anyway, let's get started. Follow my cursor. The limit as x goes to negative infinity of this numerator here over this denominator here equals, now nothing cancels, so there's no point in leaving that denominator in factored form. So let's do distributive or FOIL, and you'll wind up getting this from algebra upon doing distributive or FOIL. So now, that's just from algebra. Now the next thing I'm going to do is the sleight of hand. Remember, the highest exponent up top is x to the fourth, or actually the highest exponent for any of these, top or bottom, is x to the fourth. I actually want to do top and bottom. So for top or bottom, x to the fourth is my highest exponent. So I divide the top by x to the fourth and the bottom by x to the fourth, like this, where my cursor is. Okay, and then I split up the fraction by the rules of algebra and arithmetic. I can split this fraction up here and down here in a similar fashion. So up here and down here. Okay, but then I cancel terms, and that's where the good stuff is where I can cancel terms. 14x4 over x4, the x4s just cancel here and here, and I'm left with 14. This x will cancel 1 out of 4 of these x's, leaving 3 of them down here, so I get 3 over x cubed. X times x times x 3 times is x cubed. And then 8 over x to the fourth doesn't change. And again, the accompanying minus signs and plus signs come with it, of course. And then down here, the limit x goes to negative infinity in a similar fashion. I get 22 because this x to the fourth cancels with this x to the fourth. Now x squared over x to the fourth, 2 of these x's will cancel off 2 of these x's down here, leaving 2 of them behind down here. So I get 2x squared down here, namely x times x. So I get the minus the 67 over x squared. And then I get my plus 30 over x to the fourth. Nothing really happens there, so it just comes down as is. And so I get, well, so I get this. Well, really, my cursor needs to be here, but that's, well, it needs to be here. The next step I do, so now I've got, notice that as x goes to infinity, neither my numerator nor denominator will go toward 0, nor will they go toward infinity. The numerator will not go toward 0 or any type of infinity. The denominator will not go towards 0 or any type of infinity, and that's good. That means the limit of the quotient is the quotient of the limits. We don't have to worry about 0 over 0 or infinity over infinity. And technically speaking, it's okay for the one qualifier. It's okay for the numerator to go to 0. It doesn't happen here, but it's okay. It's never okay for the denominator. Well, it's not okay for the denominator to go to 0. Well, we could get some kind of infinity, but let's not get into all that. Let's just move along. It's okay for the numerator to go to 0, and it's never okay for both of these guys to go to 0. Well, I mean, they can both go to 0, but you can't do if they both go to 0, you can't do the limit of the quotient as quotient of the limits. But let's just move along. I didn't mean to ramble on there. So finally, but this doesn't go to infinity, this doesn't go to infinity, and this down here doesn't go to 0, so we can move along, and we get the limit of the quotient is quotient of the limits, and we get that. And so we can break, now we break it up. The sum and difference of the limit is the limit of the sum and differences respectively. So we get this up here and down here. And then scrolling down, but the limit as x goes to anything of just a constant is that constant. So 14 as is. Now the limit as x goes to either infinity of 3 over x cubed is going to be 0, but on this next step here, I didn't do that right away. I just took the liberty to yank out the 3. I yanked out all non-1 constants that didn't equal 1. So I yanked out the 8, Down here I yanked out the 67, and here I yanked out the 30, and I just went ahead and did the 14 and 22. You could yank out the 14 and say 14 times limit x goes to negative infinity of the number 1, but that would be kind of silly. That's okay if you want to do that just for completion. But anyway, I get all this, and then I get 14 minus 3 times 0 plus 8 times 0, PEMDAS style, that is, in the with the idea of PEMDAS in mind. And then down here, I get this. But note all these other terms, the 14 and 22 are not going to vanish, but the other terms will. And so you're just left with 14 over 22, but don't forget to reduce the fraction. That's 7/11. So what have we shown? If f of x equals the, let's go way back to the very beginning. Never mind the limit for the time being. Let's just look at what was inside the limit. This numerator here over this denominator here. That overall fraction, the whole thing, let f of x equal this entire thing here. Then you could then it's going to be the case that y equals 7/11 is the horizontal asymptote of the rational function f of x equals this numerator over this denominator. Okay, and observe that in this case it was fruitful to go ahead and just multiply through. Nothing canceled, so there was no point in leaving these factors dangling. We may as well just go ahead and do FOIL distributive to get this. So y equals 7/11 is the horizontal asymptote of this guy here, our original guy, our original term, that is. Now I'm going to leave it to you to do this, and you do it in the same fashion. You're going to need to do distributive FOIL down here. And notice my terms have a lopsided look to them, but that's okay. You're just going to go about it the same way. You'll end up, when you do FOIL distributive, you'll end up with 4 terms instead of 3. It doesn't matter. You go about it the same way. You'll end up with a 4-term polynomial on the bottom, and you just state, well, you've got a trinomial up top, but it's okay. That's not going to affect the approach any, as far as the global approach is concerned. You'll just have 4 terms on the denominator to deal with, but you go about it the same way I dealt with my problem. Okay. But anyway, you do that one, and sometimes it's better to combine with FOIL than factor when terms don't cancel. And in this case, it was better. It made life a lot easier. In fact, we just about had to be honest. So there's that. And really, to be honest with you, I don't see how we could have done this if we would not have. But anyway, yeah, actually, we had to here. But I hope this helps. So here's this is a horizontal asymptote, that a problem I really wanted to do. And that'll be all for this video. Thank you.